Hi, I'm Rachel Somerville. I'm the group leader of the Galaxy Formation Group here at CCA. And I apologize, I've missed the beginning of this wonderful day. I will go back and watch the recording because I just hopped off of an Astro 2020 Decadal Steering Committee meeting, which has been one of my activities. Other things I am interested in include developing new techniques for modeling galaxy formation. See the next slide. I've also been involved with, oh, not yet, sorry. Not yet, go back please. Sorry, that was confusing. I've also been involved with a large program with the ALMA telescope called ASPEX and doing theoretical modeling to help interpret results from that survey. I'm interested in making forecasts for intensity mapping with different lines, including C+, as well as CO and any line really. I've been very interested in the epoch of reionization and understanding whether galaxy formation works very differently in the first billion years of the universe, or whether we can sort of scale our current models back to that epoch and get good predictions and predict which galaxies reionize the universe and how and when. I've been involved with a JWST early release science team, and we've been using our models to create synthetic data, both photometric and spectroscopic, that they're actually using to test their pipelines. So the image on the right here is actually a synthetic image that we created using our simulations and modeling techniques. And we're also expanding those to make synthetic data for W1st Roman. I'm quite interested in what are the seeds of the first black holes and what their observational signatures might be. I've also been spending a good bit of my time recently working on issues of diversity, inclusion, and equity. I'm chairing the Flatiron Institute DEI committee, and I'm also a member of the recently formed foundation-wide DEI steering committee. And as I mentioned, the 2020 Decadal Steering Committee. Okay, now please go to the next slide. Thank you. So the interests of the Galaxy Formation Group are very broad. We would really like to make a link all the way from the smallest scales, and where small scales for us means scales of individual stars and black holes and supernova explosions, all the way up to cosmological scales, and understand how physical processes operate and interact between those different scales. And to be able to create models and simulations that capture this physics in a robust and physically grounded way. So most of the members of the Galaxy Formation Group are working on questions in some way related to this list here that I won't read out to you, having to do with how the large scale environment set by cosmology and structure formation influences galaxy formation, et cetera, et cetera. Most of the members of the Galaxy Formation Group are involved with a collaboration called SMAUG, which stands for Simulating Multiscale Astrophysics to Understand Galaxies, in which we're working on developing a new generation of cosmological simulations where the subgrid recipes are based on drilling down and doing smaller scale simulations instead of using tuned phenomenological recipes. We're also interested in developing and applying more robust statistical methods to validate and assess our models. And this is an area where we would like to interact more with some of the other groups who might be interested in this topic. Some group members are also working on building tools to create synthetic observations for current and future facilities. And again, I think there's interesting cross-group potential to think about not only multi-wavelength predictions, but also multi-messenger and multi-tracer. So, you know, tracers that tell us about different components of galaxies, their stars, their cold gas, their warm gas, their hot gas. And we're also interested in trying to develop new methods to solve problems in galaxy formation using this powerful technique of machine learning. And recently, 3 members of the galaxy formation group and the machine learning group have started a collaboration called CAMELS, which I don't remember what it stands for, but it contains cosmology and machine learning and things like that, which have run literally thousands of variants of numerical simulations that we're using as a sort of a platform to develop new methods in machine learning. That's it.
Okay. Hi, I'm Katie Brevik. I am a Flatiron Research Fellow at CCA. I'm primarily sitting between gravitational waves and astronomical data, which I see the intersection of those being binary stars. So I'm very excited about binary stars. I'm also excited about my 2 cats. So that's part of my COVID activity. Those are Margot and Richie. Yeah, I don't know. They're part of my identity. Okay, so the thing that I actually spent a lot of time doing in COVID was Animal Crossing flower genetics, which to some people who haven't thought about this, that doesn't mean anything, but to the people who know, I have 6 blue roses, which means that I have spent the last 4 months growing 7 generations of rose breeds to make successive colors of roses to then make blue roses. And I could sell them on eBay for like $1.50 if I wanted to. So that's a very large accomplishment in my life. So in general, my research interests are sort of encompassed in a question, which is how can we combine binary star population simulations like those that I develop and run and have run during my thesis and last postdoc? How can we combine those simulations with electromagnetic and gravitational wave survey data to infer binary interaction physics? I'm excited to be here because it feels like CCA is a big old conglomeration of ways to answer that question. Some particular projects that I'm thinking about right now are, can we constrain common envelope ejection efficiencies and globular cluster radii simultaneously with an emulator that Kaze Wong, who's a grad student at Johns Hopkins, has put together, my simulated black holes, globular cluster simulated black holes, and future LIGO data. Another project is just how many black holes and neutron stars and binaries will we find with survey data, particularly in Gaia or SDSS-5, and how are we actually going to do that? What can we do with them? And then the other project that I'm thinking a lot about with an undergrad that I've been thinking about over the summer is how does the observed anti-correlation in binary fraction with metallicity impact LISA's white dwarf foreground? And that's all. If you're excited about binaries, come talk to me.
Perfectly on time. Oh, hello, I'm Shasha Huang. I'm a pre-doc joining this fall, and I'll stay here until end of January. Now I'm a 4th-year graduate student in the University of Virginia, where astronomy department is closely working with NRAO, and I'm always surrounded by radio observers and constantly being impressed by how much ALMA can do, which is pretty cool, but definitely a kind of different habitat here. So in terms of COVID activity, I started to learn ukulele, and as you can tell, my cat Stormy doesn't really appreciate that. The other thing I did a lot is haircutting for my friends. So these 2 pictures is like from scale 0 to 10, how satisfied your haircut is. So these are like 2 ends. So feel free to find me when you look at these pictures. Research interest. I'm interested in non-thermal star formation feedback in general. I'm also interested in radiation and hydrodynamics. I hope that I can see more of its application even outside of star formation feedback. And recently, I also picked up this project with another graduate student about X-ray binary disk. So although it's a hydrodynamic simulation, but I find I'm really intrigued by these physics in there. So current research project. My current research project, the one that I'm wrapping up with, is we're trying to study this warm and hot galactic wind driven by cosmic ray pressure. And these winds depends on how you define the warm or hot. It could be like something like 10 to the 4 or 10 to the 5. And I'm also kind of interested in the acoustic instabilities in here. Oh, wow, I'm out of time, sorry. So at here, I will be studying also about cool gas, but instead of forming near the starfleet region and pushed by some sort of momentum and energy, I'll be working with how it can form via thermal instability in the cosmic ray wind. So yeah, I guess I have more things I can talk about. Please find me if you're interested, but I'll just stop here.
Hello, can you hear me? Yes, okay, I'm Ashley Villar. I am a new postdoc just coming from my PhD at Harvard. I'm a Simons Junior Fellow at Columbia, but I spend a few days here at CCA. I'm unfortunately only here for 1 year. I'm starting as an assistant professor at Penn State in July of 2021. So my COVID activity, I do fun projects with my husband a lot, who's a material scientist. And our latest project is we're working on a nylon-based reusable pour-over filter for coffee. So if you're interested in beta testing and like want a free filter, please tell me, and I would love to give you one. We're hoping to make a Kickstarter with it. Okay, so research-wise, I do time domain astrophysics, looking specifically at extragalactic transients. So things like core collapse supernovae or kilonovae, just exotic explosions are what I'm mainly interested in. And I do this with a mindset of data-driven astrophysics, so things like machine learning and statistics, with the idea being that time domain astrophysics is entering this new era of big data thanks to the Vera Rubin Observatory. So right now, I'm working with Shirley Ho's, the Cosmology Cross Machine Learning Group, on a fun anomaly detection method to look for exotic transients in a physics agnostic type of way using neural networks. I'm also thinking a lot about other ways you can do active classification of supernova and using both light curves and images directly scientifically. So at Columbia, I'm working with Brian Metzger, thinking about what are some fun exotic transients that maybe we can find in LSST. So specifically this weird idea of a special type of stripped envelope supernova making our process material. And finally, I'm desperately looking for a student to help me work on TESS data, to use TESS, the exoplanet mission, to look for fast extragalactic transients. Yeah, that's it.
Do we have Diane Selim here?
No, she's probably sleeping right now. She's in Japan.
Do you want to say a few words about Diane for us? I think she might be your students from Japan.
Yeah, so Diane is a first-year graduate student starting at Rutgers, but she's been working as an intern since the summer, and she's been primarily focused on developing machine learning algorithms for studying MHD turbulence. So she's been in particular trying to develop neural networks that also take into account PDE constraints for the purpose of developing super resolution. So going from training on lower resolution data sets, training a network to extrapolate to higher resolution. And then ultimately the goal is to then do some tests where we have some higher resolution simulations and see how the network is able to reproduce or not reproduce the statistics of MHD turbulence in terms of like things like the energy spectrum. So Diane, as I said, she's a starting graduate student at Rutgers, so she'll be around for a few years, and I think she'll have a lot of overlapping interests with people interested both in machine learning and also in star formation, which is something that she's also an expert in from her undergrad and master days at ANU.
Thank you, Blaisley. Next slide, please.
Hi, everyone. I'm Barry McKernan. I'm here this year from CUNY BMCC and AMNH. I did many things. I tried many things to stay sane during COVID. I failed at most of them. These are some of the things that sort of helped keep me sane. I put Zoom gaming down. That degenerates into Zoom drinking, but Zoom gaming sounds classier. My research interests span many things. Right now, I'm sort of focused on gravitational wave sources, So I spend a lot of time with the gravitational wave folks here, but also the compact objects. Generally, I'm interested in things that might go bump in AGN disks around supermassive black holes. And in particular, I like to tell LIGO folks that effectively they have a giant machine for reverse engineering AGN. And so I like to encourage efforts in that direction. Current projects I'm interested in. I'm interested in dynamics in AGN disks. I'm particularly interested in what O3A will look like. I anticipate for inside baseball folks, an asymmetric distribution in chi-effective, which I think will tell us something really useful about gas stalling and retrograde binary ionization in AGN disks. But I'm hoping that in 3 weeks we'll learn more. I'm very interested in talking to someone about the pumping of eccentricity in binaries in AGN disks. And I'm very interested in time domain AGN astronomy in general and disentangling false positives from potential EM counterparts.
Hi, I'm Winston Harris. I just finished up my undergrad at Middle Tennessee State University. And because I'm indecisive and couldn't settle on one major, I did 4. Besides that, I've been working with the National Society of Black Physicists program this summer to do with the Simons Partnership to do research on simulating RV exoplanet detection with varying scheduling and noise models, which I'm continuing research today with David Hogg and Megan Bedell. My COVID activities have been playing music, learning sign language. I have a friend that's a speech language pathologist who teaches deaf children, and they've been showing me a little bit of that. I wouldn't say I'm conversational, but it's I can at least spell some stuff. Besides that, I'm taking a gap year while I'm applying to PhD programs, and I'm looking at programs where I could research fluid dynamics, galactic dynamics, or control theory.
Hi, my name is Simona. I'm currently also, like Winston, taking a gap year between undergrad and grad school. I just graduated from Smith College in Massachusetts, and now I'm spending the first part of this gap year at the CCA, and I'm quite excited to be here. My COVID activities have been one, I've been reading just a lot because now I have the time to do that, and getting outside as much as possible before the winter hits. So going on lots of long walks. I really love rock climbing, and I've been able to get outside and do that a couple of times, although the gyms are all closed. And so that's one of these pictures here. Been running, hiking, biking, all the things. My research interests are primarily gravitational wave data analysis. So I'm in the gravitational waves group here. And the current projects that I'm working on are, as Will was talking about a bit earlier, working on population level analyses of binary black holes using LIGO data. Specifically, I'm interested in looking at the distribution of spin across the binary black hole population, and doing that in a couple of different ways. And I'm also working on a project that's looking for degeneracies between different ways that higher order modes can show up in gravitational wave data, specifically orbital eccentricity and the mass ratio. So I like sort of statistics, population level things, as well as looking at some of the more specific things related to gravitational wave signals themselves. That's it.
The next one is Zachary Whoops. I think Simone might say a few words about him. Actually, Simone is not here, but so let's skip to the next one.
Hi, I'm Lisa Beignet. I'm currently still in PhD in France. I'm supposed to finish on Monday, if everything goes well. And I will be starting as a research fellow at CCA on November 2. I mostly work on stellar physics, on both data analysis and also with a little bit of theory. In the first part of my PhD, I've been focusing in large dataset analysis by using machine learning techniques, mostly for the characterization of solar type stars by using asteroseismology. And my more recent project has been to look for the signature of internal magnetism inside stars on their oscillation frequencies. And so we have been trying to find a way to investigate the internal magnetic field inside star, which is a very exciting project. And so, yeah, I hope to collaborate with you all when I start and see what you're doing here.
Thank you. Stefan?
Unmute myself. Can everybody hear me? Okay, good. I was just saying we're going in reverse alphabetical order. So, anyway, I'm Stefan. I'm here on sabbatical from Brown University. I'm also, I guess, a Simons Senior Fellow, and something I'll be doing a lot this year as well is taking some of this time to properly be the president of the National Society of Black Physicists. Well, we will also be working with the foundation on some really some nice initiatives. Let's see. I guess I'm happy to be here because I'm here to learn new things and learn hard things, and hope to interface with some of the things that I work on. So, you know, for most of my career, I've been working on physics of the early universe, cosmic inflation. I was one of the first people to develop the model in string theory for cosmic inflation. How that relates to quantum gravity, the wave function of the universe, things like that. Working with people talking to people like Paul Steinhardt and, you know, about pre-Big Bang stuff, alternatives to inflation. Tomorrow I'm giving a colloquium. I'll talk about the relationship between baryogenesis and dark genesis with some interesting observational connections, and that's kind of where I go into the physics of the contemporary universe. I guess that's what everybody calls astrophysics. Recently been doing some stuff with my postdoc Evan, who's now at Chicago, and Colin Hill on the Hubble tension, where they really took the lead and wrote a nice paper on. I've worked a lot on gravitational waves. In fact, my first PhD student is Nico Yunez. And so we work on I work on gravitational waves with, you know, looking with an eye towards beyond the standard model physics. Recently did a nice paper with something interesting there, and very interested in spin for as a diagnostic of maybe looking at parity violation and general relativity. So I also work on dark energy and the cosmological constant problem, like linking those two things together, and how that is linked with modified theories of gravity. So recently put a paper out, 2 papers out on that, that predicts dark energy as a result of solving 2 of the 3 main parts of the cosmological constant problem. And then I'm working a lot with, I work with David on dark matter theory and some observation, and most recently with some students, you know, mainly them, we've jumped into some machine learning related to lensing and certain models of dark matter, and we're excited to interact with the whole group and others on that, and looking at dark matter also as a condensed matter system, and I'll talk a little bit about that at the colloquium tomorrow if you can make it.
Thank you, Stefan. We have Q&A sessions now, I think. Am I correct? Or should we have a few people who haven't spoken, who want to speak first before Q&A? Yes, Vivi, would you like to speak?
Sure. Hello, I'm Viviana Quaviva. I'm an associate professor in CUNY SUTEC. I'm also a friend of CCA. For the last few years, I spent 1 or 2 days a week here. I guess I'll go with the format. My COVID activities, I was really very in awe of, all the great activities you guys picked up. I don't know, for us, I was on sabbatical at University of Barcelona when it all started. So I was in Spain. It was far from home. Spain has one of the strictest lockdowns ever. So, children couldn't literally get out of the house for like 6 weeks. So I don't know, like I went into therapy. My goals were not divorcing my husband, not ruin my young daughter's life. And I felt like I just having been able to get through that was amazing. In terms of science, I think my interests lie in, galaxy evolution mostly, and just, understanding physical properties of distant galaxies, things like, star formation histories in particular, but not just that, like metallicity history and so on. For a long while, I worked on spectral energy distribution fitting. And in the last maybe 5-8 years, I got, like many of you, a bit more into machine learning. And I guess, the main science question I've thought about for the last year has been, how can we get to trust the simulations, right? If we knew they were perfect, we would believe that we can apply these methods on data and trust the result, but clearly they're not. So, how can we in general approach the problem of, what does it take for us to believe them? And if not, like what kind of maybe domain adaptation techniques we can use to, to make them more trustworthy, to make them more useful for science. And then I guess I'm at a school with a pretty high teaching load, and for me something that is really important is also like the pedagogical aspect of machine learning. So I've been teaching it to our undergrads for a while. I'm writing a textbook that is geared towards undergrads for this, and I feel like teaching these kind of things can really help with social mobility issues. Now we've seen our first cohort of students that is getting really great jobs, and so I think a lot about what kind of skills should someone who comes out of school with a bachelor in physics have, so that they can like go out in the world and do awesome things.
Thank you, Fifi. Anyone else would like to speak a few words? You can just unmute yourself and do it, I think. Right, seems like everyone are done talking, except we'll have a small discussion, I guess, the Slido questions. Okay, who are the climbers at the CCA? I counted a few here. I counted, I think, Simona and Ken. I'm semi-climber. Oh, okay. And any other questions in terms of, okay, for Winston, why control theory? Why are you interested in control theory?
Generally, I'm interested in dynamical systems, stuff that moves around. So a control theory, I would like to have something that has active input and be able to like a physical motor to be able to track something that is moving very quickly or in a sporadic pattern, and just sort of combining my engineering background and my physics background.
And what is cool in quantum gravity these days for Stefan?
That's a tough one. Well, I can tell you something that I think is interesting, and it kind of got to it actually with, there are two things that I think are kind of interesting, I think could have impact for the early universe, but in terms of quantum gravity. One is, Hartle and Hawking had this wave function of the universe. I was actually going to bother David about this. Neil Turok, one of David's old friends, has kind of revisited this whole, the wave function of the universe is some quantum state that basically semi-classically gives you something that looks like inflation, but it had all these problems, okay? And there's a heightened debate, that's a resurgence of this whole thing that I think is kind of interesting. We can talk more about that. The other thing I think is interesting is a formulation. It seems that a lot of even opposing theories of quantum gravity point to. It's called matrix quantum, matrix quantum mechanics. It's called matrix theory, and that is turned out to be really interesting in terms of thinking about an early pre-Big Bang phase, actually, where actually there was basically there was no space-time. And the idea is that from this matrix theory, space-time could emerge. And so some people are talking about this. That's kind of my pet peeve at this moment in terms of like things that I think about in quantum gravity.
Thank you, Stefan. And the final question for Rachel: how does CCA versus SFY-DEI groups overlapping and different?
So there's a Flatiron-wide DEI committee, which has 2 representatives from each of the centers. So there's no real formal CCA committee, but we are part of the Flatiron-wide committee, and that was started about a year ago. And actually the first major accomplishment of that committee was to start a program called the IDEA Scholar Program. And we're very honored that Stefan is our first IDEA Scholar. So you can read about that and other aspects on the webpage that I put in the chat. So then this summer, leadership made the decision to start a foundation-wide effort, which covers workforce and workplace issues, outreach, and grant making. So this is really going across the entire foundation, almost every aspect of the foundation. And so that steering committee has now been formed. I'm the representative from the Flatiron Institute, but then there are also representatives from HR, from operations, from grant making. And the idea is that in different parts of the foundation, we'll form working groups to work on specific issues. So if you look on this website, there's an email that you can send an email to if you're interested in being part of a working group, or if you have suggestions for issues that you think working groups should be working on. So hopefully that clarifies. The idea is that this central foundation-wide committee will sort of be a way to communicate and coordinate these efforts across the whole foundation.
Thank you,
and
Rachel.
the CCA reps to the Flatiron committee are me and Megan Bedell.
Thank you, Rachel. I was just gonna call on Stephanie to say a few words about the lunch talks.
So, these 2-minute intros were awesome, but you could have a whole 20 to 25 minutes to talk about your work. Not only could you, but you are supposed to. So, all of you new people, sign up. I think I've tried to email at least a chunk of you, and if I haven't emailed you, please feel free to email me and I can help you fill in your name. Or you could just fill in your name in the Excel spreadsheet, which would be amazing because I really want to hear more details about everybody's research. And if you are an oldie but a goodie here at the CCA, you can also still talk. We're looking for any internal speakers to talk. So thanks, Shirley.
Thank you, everyone. I'm going to pass the mic to David for final remarks now at this point. David, here you go.
Great. Well, first, just want to thank everyone for a really wonderful set of introductions. It's going to be a really terrific year. It's great to welcome you all. It's always exciting to see just the range of interesting things people are thinking about. And, we, I think, managed on Zoom to do the best we can, which is sort of all that we're striving for at the moment. As people should know, we invite people to come to our apartment afterwards. We'll have we had too many people we went over the New York City legal limit of 25. So we're doing it in 2 nights, tonight and next week. Looking forward to have people over, just in case, if you are coming over tonight. We're at 100 West 18th Street, that's 18th and 6th, that's about a 5-minute walk away. And we should be, we're apartment 10A. And we have a roof above us that's ours. So if you're coming, come up to the 10th floor and then walk up the stairs one flight and we'll be on the roof. And look forward to seeing you up there. And finally, we have a staff meeting tomorrow at 9 a.m. The primary focus there is to talk about how we feel this year's going. You know, to think about what activities we're doing in person, what we're doing hybrid, what we're doing fully online. Really, it's to listen to your ideas about what changes you think we should be making in group activities, lunches, colloquium, other things that we should be doing to sort of best function in this period. I think we're likely to be in the current mode for another several months, so that we should, want to be the best place we can for all of you. So it's really to think about how to best operate. So I hope most of you will be able to join, and so come to it with your thoughts on changes we should be making, and also things that are working. I mean, I think it's really valuable to hear from people about things you're happy with, as well as things that need to change.